Welcome back to class. Today we're going to delve into the science that helps us understand how our planet's climate is changing, and we'll start to consider what those changes to the planet's climate mean to our health. So, climate change, a topic that you have undoubtedly heard about before. What's it all about, and how do we know what's going on? Well, most people, when they hear about climate change, think about the change in the average global temperature, and people have been told that the planet's average temperature has been going up. How do we know that? Well, we have thermometers, and those thermometers have been around for a long time. There have been enough thermometers to get a decent idea of what the global average temperature is, probably for about 130 years now. And the graph you're looking at is a graph that is provided by NASA, which shows the global temperature since 1880. What this graph shows is not the absolute temperature, but it's the temperature over time compared to a baseline of 1951 to 1980. So you'll see there's a zero on the graph. Let's have a look at it more closely. So there's a zero over here, and that corresponds to the baseline period of about 1951 to 1980. Over this period of time, you'll see that the temperature has gone from about minus 0.3 degrees Celsius to plus 0.51 in 2003. So that's about 0.7 or 0.8 degrees of difference in the global average temperature over the last 130 years. So let's have another look at this data. Instead of looking at it on a graph, let's look at it on a map. And what this map is going to show you is that same data, but pictured on a map. And what you'll see is the temperature change, what's called the temperature anomaly. That's what was described on the previous graph, the difference from a baseline level of 1951 to 1980 over time. And what you'll see is that the planet is warming. But what's important to note is that the planet is not warming equally, so that areas closer to the poles have been warming more than areas near the equator, and that some places are in fact getting cooler. So when we talk about global average temperatures, we're talking about the summation of temperatures all over the planet, and you can see here that the warming is occurring much more rapidly in the Arctic, and that's of great importance to what climate change means for health, a subject that we will come back to. This is a map of where the thermometers are. Right now there are about a little over 2,000 thermometers on Earth on land looking at temperatures across the globe. And what's nice about this map is it not only shows where the thermometers are to give you a sense that the thermometers are distributed around the globe, but how long they've been around. So as you move from blue to red in this map, you get a sense for how long the thermometers have actually been there before. Interestingly, there are temperature records going back hundreds of years. The oldest is from Berlin. That is the oldest continuous temperature recordings from Berlin. That goes back to 1700. But there are thousands that have been around for decades. What's important to note about this map is that obviously temperature recordings are not evenly distributed around the globe. There are many more in North America than there are in Africa, and the ones in North America have been around longer. But at the same time, there have been temperature recordings around for very long periods of time on all continents. So, what if we wanted to know the temperature of Earth going back further than we have a temperature record from thermometers from? So we've really only had enough thermometers around in a broad enough distribution to get a good sense of what the global average temperature has been for, as I said, about 130 years. In some places longer than that, but on a global scale, probably about 130 years. What if we wanted data going back further? Where could we look? Well, one place we can look is ice. So this map of Antarctica shows several places in Antarctica where ice cores have been drilled to look at what the temperature of Earth was going back hundreds of thousands of years. And in these ice cores, which looks like this, can be captured the history of Earth's climate. Now, it hasn't just been Antarctica where these ice cores have been drilled. They've been drilled in Greenland. They've been drilled in glaciers in North America. There are records from all over the frozen areas of the planet to try and discern what the temperature has been on Earth going back thousands of years. As snow falls on Earth and ice forms, it sinks downward. So the deeper you go in these cores, the older the temperature record. And right now we have temperature records going back 800,000 years. So the logical question you would ask at this point is, how do we use ice to figure out what the temperature of Earth was going back that far? And this is a picture showing what a cross-section of one of those ice cores would look like. And in it you can see lots of ice. Those are the purple, brown, and black colors here. And that's ice put under polarized light. And you can look at that ice and determine what the temperature is by looking at the composition of water. So it turns out that not all water is created equal. And water, as we know, is H2O. So there's 2 hydrogens and 1 oxygen. And oxygen has 2 different forms. There's an oxygen that has a weight of 16 and an oxygen that has a weight of 18, atomic weights. And these are naturally occurring. What's interesting about that is those 2 different weights make water as a molecule have a different weight. And water that's slightly heavier condenses a little more readily, and water that's a little lighter evaporates more readily. So what's displayed in this graph down here is that heavy oxygen-enriched water condenses over mid-latitude, so it's warmer near the equator. What evaporates is the lighter water, and as it goes towards the poles and things get colder, you see about a 5% lower concentration of heavy water than an ocean. What that means is that as temperature goes down, the concentration of heavy water also goes down. So when you look in the ice core in Antarctica or in the Arctic, you can use the ratio of heavy water with oxygens that weigh 18 versus light water with oxygens that weigh 16 to figure out what the temperature was at the time, because the temperature, again, will determine the relative amount of the heavy water that condenses and the lighter water that evaporates. And that's how scientists have been able to look back over hundreds of thousands of years in these ice cores to determine what the temperature on Earth was. What's nice about the ice cores is that we have ice cores, as I showed on that map of Antarctica, not only from all over Antarctica, but from the North Pole as well. And the temperature records are consistent, so that we have multiple data points that give us a sense of the Earth's climate over time. And all of those, as we will see in a bit, indicate that the present time is a period of warming. But what other signals might we find that the Earth's climate is changing? Aside from the temperature itself, let's pretend for a minute that we didn't have the ice core samples or we didn't have thermometers. What other evidence could we find that the Earth's climate is changing? There are lots of other examples, and one of the most compelling is the way the natural world has been responding. Going back to the 19th century, naturalists all over the world were very diligent in recording, for example, the time at which flowers bloomed in spring. And one of those naturalists was Henry David Thoreau, who spent 1845 to 1849 at Walden Pond, not far from where we're filming this class in Boston. And Thoreau measured the first blooming of many flowers around Walden Pond back in the 19th century. And people have returned to Walden Pond for many years and recorded the date of blooming. And what this graph shows is how the dates of blooming of flowers at Walden Pond have changed over time. What you can see on this graph is Thoreau's data, which goes back to 1850, showing that the date of flowering was around 15 of May. Other people went into Walden Pond around 1900, and the median, the average, was around the 10th of May. And then in this paper, researchers went out and went back to Walden Pond, and they looked again, and they found that the average was closer to the 5th of May. And you can see that over time, as the climate has warmed, the date of flowering of these plants has gone down. So we see responses to warming in the natural world, and not just in flowers. there have been melting of glaciers. So this is a picture of Muir Glacier in 1891 and 2005. The two pictures you see are essentially taken from the same vantage point. In the picture from 1891, you can see that clearly the glacier is bigger, and in 2005 it's much smaller. The map of Alaska on the bottom shows you where Muir Glacier is, but of course it's not just Muir Glacier that's been melting. What this map shows you is the melting of glaciers all over the planet since 1970, and you'll see that there are lots of large red dots which indicate that glaciers have been retreating, in some cases by over a meter a year, since 1970. I particularly want to point out South America. In the Andes, there's a large red dot where the glacial melt is critically important to the water supply as well as to the energy supply of the Andean countries. And the melting of glaciers there is not just a loss of ice, it's in fact a loss of a critical resource, which is fresh water. So flowers are blooming earlier, glaciers are melting, but we can look at other signals in the living and physical world and ask the same question, which is, do we see changes in, for example, the dates at which flowers are blooming or the rate at which glaciers are melting that are consistent with warming? So let's have a look at this map, which is a statement of tens of thousands of data points on this very question. This is a summary map from the Intergovernmental Panel on Climate Change, the IPCC. And what they've done is they've looked at all the available evidence that, or all the available research that asks the question, are physical and natural systems responding as one would expect given climate change? Just looking at these boxes at the bottom, just to help you understand, on the left are physical responses. So on the top box, it's number of significant observed changes. In the bottom, it's percentage of significant changes consistent with warming. And then the biological side on the right, it's the same two categories. And what you can see is that given the temperature changes, which are represented here in the colors here, between 1970 and 2004, that in North America, there have been 355, it's represented here, significant observed changes in physical systems, and 94% of those are consistent with warming. And there's data from North America, Latin America, Europe, where they have 28,000 observed changes in biological systems, 89% of which are consistent with warming. And then we look all the way over here, and there's just terrestrial, where there are 28,586 changes in the biological systems of the world, and this can also include migration of species, so birds, land animals, trying to get out of the heat. 90% of those are consistent with moving towards the poles, so species will move to get out of the heat by moving away from the equator. And on a global basis, so if you look at all the data that was compiled here, 94% of physical data points and 90% biological data points, which is to say, if you looked at all the glaciers and sea level rise and so forth, 94% of the 765 data points are consistent with warming, and of the 28,671 in the biological world, 90% are consistent with warming. So this is a summary statement about the evidence that shows that both the physical world and the living world are responding to warming. So at the next class, now that we've considered the signs that the planet is warming, both in the temperature record and in evidence in the living natural world, we're going to turn our attention to how science understands how greenhouse gases are contributing to this warming that's been observed. I'll see you next time.